Hi, my name is Cindy Skipper, and I'm a PhD student in the Earth and Environmental Science Department at UTA. The title of my poster is Influence of Snow Cover on Luminescence Dating of Glacial Moraines. I'm going to start with my introduction. The basis of this project is using luminescence dating on morainal boulders. Luminescence dating is where you have something called OSL intensity, or optically stimulated luminescence, and it's something that's held inside of rocks. So as there is more exposure to sun, the luminescence signal bleaches away to greater and greater depths. So using this process, we can find the date that glacial boulders were deposited on Earth's surface. So you can see this is a glacier, and as it melts, this boulder is becoming exposed to sunlight, and eventually it rests on the surface of the Earth. So through time, as glaciers melt, you have these piles of rocks where the rocks have been exposed for a certain amount of time. And if we take several rocks from several locations, we're able to find the timing and the rate of glacial retreat. Unfortunately, a lot of people are afraid of using luminescence in certain environments because they're not sure if snow cover or ice cover can affect how the sun bleaches away the luminescence signal. So in this study, we're going to use MATLAB to find some theoretical results, and then we'll apply it in real life. So here for the theoretical results, we made simulated OSL depth profiles for 1, 10, and 100 years. So that's these three graphs right here. These different colors are showing how many months out of the year sunny it was. So this darker color, the sample was darker for longer. This lighter color, it was lighter for longer. So 12 months out of the year, it was sunny. There was no snow or light exposure. Or sorry, there was no snow or ice cover. So this pink line is showing that. So as you can see, the difference between absolutely no snow and ice cover is the same for when there was snow and ice cover for different variable amounts. And this is repeating the pattern for 10 years and 100 years. So it doesn't really make a noticeable difference. It's just showing that through time, the signal bleaches further and further away the longer that it's exposed to light, which does make sense. And it does that evenly, whether there's snow cover or no snow cover. But that was just with a consistent snow cover day history. So this is the temperature record reconstructed for 12,000 years. And we compared this with known snow cover days that were taken from Billings International Airport. So we found the correlation where there are more snow cover days when it's colder, and when it's not as cold, there are less snow cover days. So using the data from these two charts, we were able to make this, which is our simulated Holocene snow cover day history. So we were able to do different exposure ages. In this chart right here, this is like just a summary of it. So we did simulated ages for 500, 5,000, and 10,000 years. This true age right here is simulated from the variable snow cover day history, which is this graph that we made. So this is like a realistic setting, or the apparent age. So apparent age is from just a constant snow cover day history, or what we were doing up here. So this is the ratio. You can see it's almost a ratio of 1 for all of them. So what we're seeing is that there's not a super big difference for if there's a variable snow cover day history or if there's a constant snow cover day history. We're not seeing that there's a significant difference for snow cover or ice cover at all. So we're not thinking that we need to correct or mitigate this effect at all. So in practice, we went to the Beartooth Mountains, which is also in northwestern United States, and we took different samples. So there's another way to date rocks called beryllium-10 dating. So beryllium-10 is something that accumulates, and it's not affected by snow cover or ice cover. So if our OSL results are in agreement with beryllium-10 results that have been taken previously, then we know that it's for a fact that OSL is not affected by snow or ice cover. So the samples that we took them in summer of 2024. We used boulders that had previously been dated by beryllium-10 by another person. We took the samples from locations with large, relatively flat boulders. So we know that the boulders haven't been tipping, and we know that the snow cover is even along the whole surface of the boulder. It's not piling up in certain locations. And then we also took samples from new boulders, which we just sampled to expand the previous data set and also to create known age surfaces for future expeditions. So this is a location site. This is Little Glacier Lake Moraine from a distance. So for this project, we'll talk about 507, 511, and 505. That's our UTA sample numbers. So this is where we drilled away the rock, and we have a rock core. So we took that core and we processed it in our luminescence lab. And so these are the results from that. We have the IR50 age and the post-IR IR225 age. Those are just two different settings on our machine. So those are just different OSL signals. So we have pretty similar results for the IR50 and post-IR IR225 results per sample. So that's what you're looking at here. And then here is where we have those results, luminescence age versus the beryllium-10 data, which had been previously recorded. So this is the fit line. So you can see that there is agreement between the post-IR IR225 ages for 505 and 507 and a little bit 510, and then agreement for the IR50 age for 507. So there's not super strong correlation with the predicted ages. However, this is just a small sample set. So since there was not super strong correlation, for future work, we could do additional sampling. This is a map of the area. So what we were doing was Little Glacier Lake. There's left and right moraines. So we were doing both of those moraines. But if we did Emerald Lake or Triangle Lake, hopefully those results would be more accurate since those are younger ages, which luminescence dating works better for younger ages. And we would be able to compare even more beryllium-10 results with those. So we have a tentative trip to the field scheduled for this upcoming summer 2025.